In this episode, we make 3 learning types feel simple and useful because on an AI audit exam, you are not being tested on math, but you are being tested on whether you understand what kind of learning is happening and what that implies for evidence and risk. The terms supervised learning, unsupervised learning, and reinforcement learning can sound like academic categories that only matter in a classroom, but in auditing they matter because they change what data is used, what success looks like, and what kinds of failures are likely. If you cannot tell them apart, you might misunderstand what a model is claiming to do, and you might ask the wrong audit questions. If you can tell them apart, you can move faster because you know what to look for, what artifacts should exist, and what controls might be needed. The goal is plain language clarity that you can recall under pressure, not technical perfection. By the end, you should be able to hear a scenario and quickly identify which learning type is being used and why that matters to an auditor. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Start with the simplest idea. Supervised learning is learning with answers provided. That means the training data includes examples where the correct output is known, like emails labeled spam or not spam, transactions labeled fraud or not fraud, or images labeled with what object is present. The model learns patterns that connect inputs to those known labels, so it can guess the label for new cases. For audit thinking, the most important implication is that supervision depends on labeling quality, because the model is being taught what correct means by the labels. If labels are inconsistent, biased, or simply wrong, the model will learn the wrong lessons. That creates a straightforward audit question. Who created the labels? How were they validated? And what checks exist to ensure labeling accuracy? Another implication is that performance can be measured directly because you can compare the model's guesses to known answers on held-out data. This makes evidence like validation results, performance thresholds, and error analysis central to supervised learning audits. If a scenario describes a model that predicts a known category, supervised learning is often the default assumption. Unsupervised learning is different because the training data does not include those provided answers. Instead of learning to predict a label, the model looks for structure in data on its own, such as clusters, groups, patterns of similarity, or unusual outliers. A simple way to say it is that unsupervised learning is learning without a teacher telling you what the right answer is. In practice, this is often used for tasks like grouping customers into segments, finding unusual behavior, or discovering patterns in data that humans have not defined in advance. For auditing, the key implication is that success is harder to define because there is no single correct label to compare against. That means evaluation relies more on whether the discovered patterns make sense, whether they are stable over time, and whether they lead to useful and safe decisions when humans apply them. An auditor's questions shift toward interpretation and governance. How are the clusters used? Who validates that the groupings are meaningful? And what controls prevent people from misusing patterns as if they were absolute truths? If a system claims to discover new categories or detect anomalies without a labeled training set, unsupervised learning may be involved. Reinforcement learning is different again because it is based on learning through feedback from actions. Instead of learning from labeled examples or just observing patterns, the system interacts with an environment, takes actions, and receives signals that act like rewards or penalties. Over time, it learns which actions lead to better outcomes under whatever reward definition was chosen. A plain language definition is that reinforcement learning is learning by trial, feedback, and adjustment, like training a system to make a series of choices. This learning type often appears in settings where decisions unfold over time, such as optimizing a process, controlling a system, or choosing actions in a changing environment. For audit thinking, the key implication is that the reward definition is crucial because the system will optimize for what is rewarded, even if that reward does not capture what humans truly care about. If the reward is poorly designed, the system can learn harmful strategies that technically increase reward while violating safety or fairness expectations. That leads to audit questions about who defined the reward, what constraints exist, how safety is enforced, and how behavior is monitored. Reinforcement learning also raises strong governance concerns because trial and error learning can be risky if it happens in real-world environments without safeguards. Now let's compare them in a way that makes the differences stick. Supervised learning is about mapping inputs to known answers, which means labeled data is central and performance can be measured against those labels. Unsupervised learning is about discovering structure without known answers, which means interpretation and responsible use of patterns is central. Reinforcement learning is about choosing actions based on feedback, which means the reward system and constraints are central. Each type, therefore, has a different kind of evidence trail that an auditor should expect. Supervised learning should produce labeling documentation, training and validation results, and clear metrics that tie to requirements. Unsupervised learning should produce documentation about how patterns are interpreted, how stability and usefulness are evaluated, and how outcomes are monitored when humans act on the results. Reinforcement learning should produce documentation about reward design, safety constraints, testing in controlled environments, and monitoring for unexpected behavior. When you attach evidence expectations to learning types, you can answer questions faster because you know what artifacts are relevant. A common beginner misconception is that supervised learning is always better because it has clear labels and clear accuracy metrics. In reality, supervised learning can still fail badly if labels reflect biased past decisions or if the training data does not represent the real environment. Another misconception is that unsupervised learning is more objective because it does not use labels, when in reality it can still reflect bias in the data and can produce groupings that are misinterpreted. Another misconception is that reinforcement learning is only for robots or games, when in reality the underlying idea of learning from feedback can appear in recommendation systems and optimization settings as well. Auditors care about misconceptions because they lead to wrong governance choices, like trusting outputs without understanding limitations. The exam can test this by offering answer choices that treat a learning type's outputs as if they are guaranteed truths. The safer, more audit-aligned choice usually recognizes uncertainty and emphasizes validation, monitoring, and clear decision rules. Let's anchor supervised learning with a simple scenario. Imagine a bank wants an AI model to flag potentially fraudulent transactions. They have historical transactions labeled fraud or not fraud, and they use those labels to teach the model patterns. The audit questions begin with the labels. How was fraud confirmed? What errors exist in the labeling process? And are there biases in what gets investigated? Then the audit moves to performance. What error rates are acceptable? How does the model perform on different transaction types? And how often is it reviewed? Then the audit checks use and oversight. Who reviews flagged cases? What happens when the model misses fraud? And how decisions are logged? Notice how the supervised setup makes the evidence trail feel concrete. You can ask for labeled data sources, validation reports, and documented thresholds. You do not need to know how the model calculates. You need to know whether the learning process is reliable and controlled. Now anchor unsupervised learning with an equally simple scenario. Imagine a retailer wants to group customers into segments based on buying behavior, but they do not have labels that define which segment each customer belongs to. The unsupervised system finds clusters that appear similar, and then humans interpret those clusters as meaningful groups. The audit questions shift because the model did not learn correct labels. It learned patterns that may or may not align to business reality. An auditor asks how the clusters were validated, what assumptions were used in interpreting them, and whether the clustering remains stable over time as customer behavior changes. Another key audit question is how the clusters are used, because using clusters to personalize marketing is different from using clusters to deny access to services. If the use case becomes high impact, the controls should be stronger because mistaken interpretations can harm people. Unsupervised learning makes interpretation a key risk, so governance must control how discovered patterns become decisions. Now anchor reinforcement learning with a scenario that makes the reward idea easy to grasp. Imagine an AI system is used to optimize the order in which customer service actions are taken, with a goal of reducing average resolution time. The system might try different action sequences and receive feedback, such as faster resolution giving a positive reward. If the reward only focuses on speed, the system might learn shortcuts that close tickets quickly without actually solving customer problems. which could increase repeat contacts and frustration. An auditor immediately sees that reward design is shaping behavior, and that reward design must match true objectives and constraints. The audit questions include what the reward is, who approved it, and what safeguards exist to prevent harmful strategies. Another question is where the learning happens, because learning by trial in a real customer environment can create unfairness or inconsistent service unless tightly controlled. Reinforcement learning introduces the risk that the system optimizes the wrong thing very effectively, so oversight must be especially intentional. Another important audit idea is that real systems can combine learning types, and the exam may include scenarios where the boundaries are fuzzy. For example, an organization might use unsupervised methods to find clusters and then later label those clusters for supervised training. Or they might use supervised models but adjust behavior over time using feedback loops that feel reinforcement-like, even if they are not full reinforcement learning. For beginners, the goal is not to classify every hybrid perfectly, but to identify the dominant learning approach and ask the right audit questions for that approach. If labels and accuracy against labels are central, supervised thinking dominates. If pattern discovery and interpretation are central, unsupervised thinking dominates. If action feedback and reward optimization are central, reinforcement thinking dominates. This strategy keeps you from getting stuck on edge cases and helps you answer exam questions by focusing on what evidence would be most relevant. Learning type also affects what can go wrong in predictable ways, and knowing those failure patterns helps you choose the best answer when options are close. In supervised learning, common failure patterns include bad labels, training data that does not match production, and performance that looks good overall but fails for important subgroups. In unsupervised learning, common failure patterns include clusters that are unstable, patterns that reflect hidden biases, and humans overinterpreting random structure as meaningful truth. In reinforcement learning, common failure patterns include poorly defined rewards, unsafe exploration, and behavior that meets the reward but violates human expectations. The exam may not use those exact phrases, but it will often describe the consequences, and you can map consequences back to learning types. Once you map it, you can pick controls that match the failure pattern, such as improving labeling governance, strengthening interpretation controls, or tightening reward and safety constraints. This is audit logic at work. Understand what kind of system you have, then choose oversight that fits the risk. By now, you should be able to say the 3 learning types clearly without needing technical language. Supervised learning uses labeled answers to learn how to predict known outcomes, which makes labeling quality and measurable validation central. Unsupervised learning finds patterns without labeled answers, which makes interpretation, stability, and controlled use central. Reinforcement learning learns through action and feedback, which makes reward definition, constraints, and monitoring central. That is enough to help you answer a wide range of Domain 1A questions, because you can tie learning type to evidence and risk. In the next episode, we will describe deep learning in a way that avoids hype and math panic, focusing on what it is, why organizations use it, and what it changes for audit oversight. For now, keep practicing one quick habit. When you hear a model described, ask whether it is learning from labeled answers, learning from patterns without answers, or learning from feedback on actions, and then let that answer guide your audit questions.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.